Reptiles are cold-blooded and like to lay in the sun to build up their body heat. Refrigerants are cold-blooded too, and they like warm places. Remember this big word from your early training days? Thermodynamics. This is why refrigerants like to go to warm places. The second law of thermodynamics states that heat flows from hot to cold and seeks equilibrium. So energy will always flow downhill and will eventually seek equilibrium. This is why we need to prevent refrigerants from flowing from one area to another that is warmer, because of the second law, which states that heat flows from hot to cold. One of the devices that we use quite often in HVAC is the liquid line solenoid valve. This valve, when energized, will open up and allow refrigerant flow when the compressor is operating. When the compressor shuts down, this valve is de-energized, stopping the flow of refrigerant throughout the system. There are many different designs for liquid line solenoid valves. In this particular design, they use a pilot valve to start the valve opening once the solenoid is energized. When the coil is de-energized, it uses the pressure of the refrigerant on the closed side to keep the diaphragm shut. This is why you will see an arrow on the body of most liquid line solenoid valves telling you to install it with the arrow pointed at the outdoor unit. The manufacturers of these valves will assure that when the valve is de-energized and closed, that when installed in the proper orientation, there will be 100% shutoff of the refrigerant. Otherwise, if you install it the other direction, they cannot guarantee that the refrigerant and the pressure of the pin will keep the diaphragm completely closed. When the coil is energized, the pilot port will open, starting to relieve the pressure of the refrigerant on the diaphragm. This will cause it to lift and cause the refrigerant to start flowing. This will be energized anytime that the compressor is running. When the coil is energized and the pilot port is open, the main valve will open and will allow full refrigerant flow through the system. When the coil is de-energized, the pilot port starts closing and the pin pressure and the refrigerant pressure starts closing the main port. And as we said, if the valve is oriented in the proper orientation, as depicted by the arrow on the body of the valve, the manufacturer of this valve will guarantee 100% refrigerant flow shutoff. Most major manufacturers talk about liquid line solenoids in their long line guides. Because pistons and TXVs do not provide off-cycle refrigeration migration protection in the heating mode, a liquid line solenoid is required for long line applications. A biflow solenoid valve provides flow control protection only in the direction of the arrow molded into the valve. The arrow must point toward the outdoor unit for off-cycle refrigerant control in the heating mode. The arrow shows the direction of flow. The solenoid should be installed within 2 feet of the outdoor unit. Also note that the equivalent length of the liquid line solenoid should be added to the total equivalent length of the line set. In this example from a major manufacturer, the liquid line solenoid valve adds 12 equivalent feet to the total line length. This is an example of a typical heat pump installation using a liquid line solenoid valve. Notice that the liquid line solenoid valve is installed within 2 feet of the outdoor unit. Here's another example of a heat pump installed with the indoor coil above the outdoor unit. Once again, the liquid line solenoid is installed on the liquid line within 2 feet of the outdoor unit, with the arrow pointing towards the outdoor unit for complete refrigerant shutoff. Also note that most major manufacturers will talk about a trap where the line goes above the TXV or metering device for the indoor coil before going back down into the metering device. This again is designed to prevent refrigerant migration during the off cycle. Making sure that the liquid line solenoid is wired correctly is the next step in the installation process. This is a wiring diagram for a typical air conditioning installation, and the liquid line solenoid is tied in with the Y signal to the contactor for the outdoor unit, so that any time that the compressor on the outdoor air conditioner is energized, the liquid line solenoid will also be energized and open to refrigerant flow. Here again is another example, and this is a heat pump. And again, the liquid line solenoid is tied into the Y circuit, so that any time that a call for the compressor is given from the thermostat, the liquid line solenoid will be energized and open the refrigerant flow. Many major manufacturers use communication thermostats for some of their high-end product. In this case, they usually provide terminals where the liquid line solenoid can be connected to be energized anytime that the compressor is called for through the communicating device. Also, one thing you want to keep in mind is the wattage draw for a liquid line solenoid. The coil ratings are rated for each liquid line solenoid, and in this example you see that AC and DC wattage for a particular liquid line solenoid can run 10 to 15 watts. In some cases, you may need to run an isolation relay to operate the liquid line solenoid if it exceeds the ratings that are given for the particular unit that you're putting it on. We also have a tech tip video on isolation relays if you're not familiar how they operate.
Go to arefco.com for more videos. Like, subscribe, and check back every week for new videos.